In Unit 1, the title is Earth Dynamics, and the topic in Unit 1 is land and sea distribution and formation. Already we have discussed about the distribution of land and sea. Today we will be discussing about the age of the earth. As a student of geography, we often say that earth is the home of man. Earth is the planet where we live and only planet known to support the life. In the earlier chapter, we have tried to understand the origin of the earth. After understanding the origin of the earth, the pertinent question that arises now is regarding the age of the earth. Throughout the history, people have been fascinated by the view that how the earth was created. The earth is old, but how old it is, and so on. The query that arises, curiosity, is how do we know the age of the earth? In this lesson, we are trying to seek an explanation to these questions. In view of these frequently asked questions related to the age of the earth, we try to seek explanations, keeping in view certain objectives. How the age of the earth is determined? What are the different methods used to estimate the age of the earth? The age of the earth is calculated by various scientists on the basis of different scientific thoughts, experimental researches, and logical argument. The scientific study of the age of the earth is called as geochronology. The age of the earth is derived based on religious concept as well as scientific concepts. Several attempts were made since the time immemorial by the religious priests, the philosophers, the astrologers to estimate the age of the earth. According to Indian religious observations, the age of the earth has been determined as 2 billion years. The religious concepts are not accepted because these concepts are not scientific in nature. Old Iranian religious priests calculated the age of the earth as 1200 years. These calculations are nowhere closer to the commonly accepted age of the earth, that is 4 to 5 billion years. The scientific concepts based on which the age of the earth is calculated can be divided into two. The first one is dating the geological formations, and two, the radioactive method or the radiometric dating. First one, that is the one which is based on geological formation and events. The methods to calculate the age of the earth and its rock formation are categorized as 1. The glacial deposit method, 2. The sedimentation method, 3. The salinity method, 4th. The rate of cooling of the earth, and 5th one is the evolutionary changes of animals, and the 6th one is the tide metals. Glacial deposit methods. Since the evolution of solar system and subsequent formation of the earth has experienced climatic changes. The earth for certain point of time was away from the sun, and after few years it was nearer to the sun. When the earth was away from the sun, cold climatic conditions were prevailed. The water in the oceans and rivers, lakes on the earth's surface has been converted into ice sheets in Antarctica, Iceland and Greenland. These ice sheets are about 5 million years old, formed during Pleistocene and Pliocene ages. These two ages is known as period of glaciations. The slow movement of the ice sheet is known as glaciers. The glaciers performed erosion, transportation and depositional activities. The rate of deposition and the age of layers can be known by the study of these layers. The method could be useful in finding the age of the earth. The method has utility to the extent that with this method possible to find only the age of the earth to the extent of 10,000 years only. Sedimentation methods. There are several methods within the sedimentation method for the calculation of the earth on the basis of the formation of sedimentary rocks and their method of formation. Igneous rocks were initially formed due to the cooling and solidification of magma. These rocks were weathered and eroded. The eroded material is transported and deposited by various geomorphic agents like rivers, wind, glaciers into water bodies to form sedimentary rocks. The sedimentation deposit was in the form of layers. The process of sedimentation and the formation of sedimentary rocks continued throughout the geological periods and still operative. Continuous sedimentation resulted into thickness of sedimentary layers. Based on total thickness and annual rate of deposition of sedimentary rocks, we can determine the age of formation of sedimentary rocks on the Earth's surface. Several scientists have attempted to calculate the age of the Earth on the basis of thickness of sedimentary rocks and annual rate of deposition, but their results are not comparable or nearer to because of the variation in the thickness of sedimentary rocks at different places. John Murray, using this method, determined the age of the first sedimentary rocks to be 176 million years. If the age of the Earth is 3 times more than the age of sedimentary rocks, then the age of the Earth is 528 million years, which is much lower than the expected age of the Earth. Hence, this method is not acceptable. Besides the differences in the results, this method also suffers from certain defects and errors. It is argued that the rate of sedimentation is not uniform every year. The rate of sedimentation also varies from place to another and from one climatic region to another climatic region. Similarly, the rate of sedimentation also varies in accordance with the lithological and structural characteristic of the rock. It is therefore not possible to measure the real depth of sedimentary rocks. Consequently, the age of the Earth calculated on the basis of sedimentation cannot be relied. That is the salinity method. The oceans at the time of their formation were believed to have contained pure water, that is water without salt content. Later on, salts from the land reach the oceans through the rivers. It is believed that rivers are the major source of oceanic salinity. Thus, in due course of time, oceanic salinity continued to increase. The age of the oceans may be calculated as the age of the ocean, in which we will take into consideration the total oceanic salt, which is divided by annual rate of oceanic salinity. Based on this calculation, Joy determined the age of the oceans as 80 million year age. The earth might have originated much earlier to the origin of the ocean. According to Joy, the age of the earth would be 120 million years. The disadvantage of this method in the determination of the earth is that it is difficult to calculate the total amount of salt present in the ocean. It is also difficult to find the annual rate of deposition of salts in the oceans. This method has some disadvantages in the determination of the age of the earth. It is very difficult to calculate total amount of salt present in the world oceans. It is also difficult task to find the annual rate of deposition of salinity in oceans. The annual rate of deposition of salinity varies from place to place and region to region, depending on the surrounding climate. Hence, this method is not accurate in the estimation of the age of the earth. Some scientists have tried to establish the correlation between the deposition of the salts in the ocean and periods of mountain building at the global scale. According to them, the amount of salts brought by the rivers would not have been always the same. The amount of salts brought by the rivers through the process of erosion and its deposition in the oceans would have gradually decreased due to continuous decrease in the rate of denudation of the mountains because of the continuous lowering of their height consequent upon subaerial erosion. The rate of deposition of the salts in the ocean would have again increased after the creation of the new mountains during the next period of mountain building activity. Based on the assumption, the scholars of the above concept have determined the age of the earth as 1500 million years. Thus, the rate of deposition of salts in the oceans may not be the same every year. It is erroneous to believe that the land areas are the only source of ocean salinity. The rate of cooling of the earth. Kelvin has suggested calculating the age of the earth on the basis of the rate of cooling of the earth. On an average, the temperature increases with increasing depth of the earth at the rate of 1 degree per 32 minutes. Thus, there is very high temperature. The temperature increases with increasing depth of the earth at the rate of 1 degree per 32 meters. Thus, there is high temperature in the interior or core of the earth. There is continuous transfer of heat from the core of the earth to the outer surface, from where heat is lost to the outer atmosphere through the mechanism of radiation. Lost heat from the earth through radiation can be determined on the basis of underground thermal gradient, thermal conductivity of the crustal rocks and the surface of the earth. The time of solidification of the earth's crust can be found out on the basis of rate of loss of heat from the earth crust. Based on the above consideration, Kelvin assumed that the whole earth was cooled and solidified at the temperature of 7000 degrees Fahrenheit. Thus, the outer part of the earth was solidified on cooling about 40 million years ago. But this estimated age of the earth as given by Kelvin cannot be accepted. It may be pointed out that radioactive elements were not discovered at the time of postulation of Kelvin's concept of estimation of the age of the earth. Lord Kelvin did not consider this fact in his method of determining the age of the earth. Therefore, this method cannot be accepted in the estimation of the age of the earth. Evolutionary changes of animals or faunal succession. The principle of faunal succession states that groups of fossils of animals and plants occur in the geological period in a definite order, and that a period of geological time can be recognized by the characteristics fossils that can be used to establish the chronological order of events. Fossils are the actual remains of earliest form of life. The appearance of the early life on the earth's surface is believed to have taken place after the earth was originated from the sun. Some of the earliest living creatures originated in the oceanic bottom. The creatures did not have the spine and belong to the protozoa class. For example, amoeba and euglena, etc. With the passage of time, earthworms, snails, cockroaches, frogs, birds, various monkeys, and ultimately man were originated. All these are multicellular in nature. The emergence of animals from unicellular amoeba to multicellular human beings is called as evolution. Tides method. The moon is the satellite of the earth. As the moon revolves around the earth and exerts gravitational force on the seawater, tides are generated. The rise and fall of the ocean water or systematic fluctuations in the water level of the ocean is called as tides. The rise of the sea level is called as high tide and the fall of the sea water is called as ebb or low tide. The moon revolves around the earth and exerts gravitational force on the sea water. With the passage of time away from the earth and hence tidal friction of the moon gradually decreased. The age of the earth is calculated on the basis of rate of decrease of tidal friction of the moon. The scientist calculated the age on this basis as 4000 million years. Tidal method of estimation of the age of the earth concentrates on the rotational force of the earth and believed that the rotational force of the earth is reduced due to the tidal fluctuation of the moon. Based on the calculation of the tidal friction of the moon and the variations in the speed of the rotation of the earth, it has been concluded that the moon moves away from the earth at the rate of 13 centimeters per year. Next method is radiometric dating. Radioactive elements generate heat after their disintegration. Based on the half-life of the radioactive elements, the age of the earth can be found accurately. Based on the half-life of radioactive elements, the age of the earth can be estimated like. In uranium lead method, isotopes of uranium have been used. Isotopes of uranium are U-238, U-235, and half-life of it was 4498.713 million years. In thorium lead method, it is seen that when thorium, that is 232, is disintegrated, it is changed into lead 208. Half-life time period of thorium is 139000 million years. In potassium argon method, it is seen that there are 3 isotopes of potassium. They are 39K, 40K and 41K. Among this, 40K has radioactive energy and it is changed into 40 AR, and the half-life time period of these elements is 11850 million years. In rubidium strontium method, rubidium Rb, that is 87, is charged into strontium Sr 87, whose half time period is 50,000 million years. Carbon method, C14 has the radioactive energy and half time period of carbon is 5570 years. Every living being has carbon degradation slowly after the death of the creatures. This method is traced to ages of 70,000 years approximately. On the basis of above methods, the age of the earth is approximately 4,500 million years. Following are few methods used to estimate the age of the earth. A. Uranium lead method. 2. Thorium lead method. 3. Potassium argon method. Next, D, that is rubidium strontium method. Then E, carbon method. According to Pierre Curie 1903, radioactive elements generate heat after their disintegration. Rutherford proposed a scheme for the calculation of the age of the rocks. On the basis of radioactive elements, all the rocks contain elements like uranium, thorium, but their quantity varies significantly from one type of rock to another type of rock. Uranium generates alpha particles after being disintegrated. Uranium, when gets disintegrated, it is changed into lead because of the excessive heat. If we are able to know the time of transformation of uranium to lead, then we can easily find out the time of the formation. Uranium and radioactive elements, the rate of the metamorphism of uranium into lead can be determined by counting the alpha particles coming out of the rock. It has been estimated that 1/67th part of the uranium will take 1000 million years to convert into lead. It is seen that the quantity of lead in the different rocks varies significantly, which denotes different rocks have transformed in different times. Keeping in view this consideration, it is concluded that the radioactive minerals were present at least 1500 million years ago. Therefore, the age of any type of rocks may not be older than 2000 million years. Thus, the age of the earth is estimated to be between 2000 to 3000 million years. Keeping in view the rate of metamorphism of uranium, The age of the earth is estimated to be between 2000 to 3000 million years. By analyzing various methods that are used in the estimation of the age of the earth, several concepts and methods have been put forth to determine and estimate the age of the earth, but none of them could be accepted by majority of the scientific community. The estimation of the age of the earth by using radiometric dating has gained significance in the modern scientific world because of its scientific bias as compared to other methods of estimating the age of the earth. Estimation of the age of the earth by using radioactive elements has gained significance in the modern scientific world because of its scientific and convincing nature than other methods.